An inverse function is a function that reverses another function. If the function f applied to an input x gives a result of y, then applying its inverse to y gives a result x, and vice versa. In order to find the inverse of a function, you, step 1, switch the x and y values, 2, solve for y, and 3, check your answer. In this example, f of x equals negative 1/4 x plus 2, which would then become x equals negative 1/4 y plus 2. In step 2, x would equal negative 1/4 y plus 2, and you would then solve for y, and then in that you would get negative 4x plus 2, which would be the f inverse of x equals negative 4x plus 2. For step 3, you can check your answers by graphing f of x and f inverse of x on the same graph and see if they are mirror images of each other over the line y equals x. This inverse function is a linear function. In order to graph a linear function, you must find 2 points on the graph. The easiest points to find are the points on the x and y axis. In order to find these points, you set y and x equal to 0. I will first set y equal to 0. That would give me 0, negative 1/4 x plus 2. When I solve, I end up with x equals 1/2. This will be one of our points. I will now set x equal to 0. So that would give me f inverse of x equals 4 times 0 plus 2. I will then end up with f inverse of x equals 2. My coordinate point will then be 0, 2. In order to graph this now, just plot your points and sketch the graph. Since the original function was f of x equals negative 1/4 x plus 2, we must graph that function in order to see if the inverse function is correct by seeing if it is a mirror image of the original function over the y equals x line. In order to graph negative 1/4 x plus 2, I will follow the same steps that I did in graphing negative 4x plus 2. I will find the 2 easiest points on the x and y axis by setting x and y equal to 0. If I set y equal to 0, I have 0 equals negative 1/4 x plus 2. If I solve, I end up with x equals 8. If I set x equal to 0, I have f of x equals negative 1/4 0 plus 2. This gives me f of x equals 2. Our coordinate points would then be 8, 0, and 0, 2. In order to graph this function, we will plot the points. So These are a few practice problems. Please take this time now to write down these problems and solve them and find the inverse functions. Number 1 is shown below. For further explanation on how to do this problem, continue watching the video. This is the answer to practice problem number 2. For an explanation on how to solve this problem, continue watching the video. For practice problem number 1, you have the equation f of x equals 4 times x plus 7 to the 4th power plus 3. The domain and range of this function is x is greater than or equal to negative 7, and the range is y is greater than or equal to 3. In order to solve for the inverse of this equation, you would start by finding what x equals. So, in order to do that, just subtract 3 on both sides. And then divide 4 on both sides. Now this part is an important step, as you need to know whether to take the positive or negative root of the expression. Because the domain is x is greater than or equal to negative 7, no matter what number you plug in for x that is within the domain, you will get a positive number. This means that you would take the positive root of y minus 3 over 4. Now you can just subtract 7, and that would give you x equals Now, in this function has the range of y is greater than or equal to 3. In order to find the inverse of this function, you would just switch the x and y values. So the inverse would be Now, since we are changing the x and y values, we would also have to change the x and y values of the range. So this would mean that the range would now become x is greater than or equal to 3. And that is your inverse function. In order to find the inverse function of problem number 2, you would switch the x and y values. So x would equal 2y minus 5, and then you would solve for y. And that gives you y equals x plus 5 over 2. Now, in order to find the inverse of this, you would switch the x and y values. So, f inverse of x equals x plus 5 over 2. Now, in order to graph the f of x and f inverse of x, you would have to find 2 points on the graph. Since they are both linear functions, as we did in the sample problem, we will find the points that cross the x and y axis for both functions. So for function f of x equals 2x minus 5, you can set y equal to 0, and this gives you the answer x equals 2.5. In order to find the y value, set x equal to 0, and this would give you -5. Now you would repeat that same thing for the inverse of the function. Now you can find the coordinates that cross the x and y axis by following the same process for the inverse function. Now that you have your graphing points, you can now graph the function. Once you graph the two functions, you would have something that looks like this. Again, this is a rough sketch of the graphs, but you can see how they are a reflection of each other over the y equals x line. One of the ways you can use inverse functions is when exchanging currency. A US dollar equals 0.90868 euros. Exchanging currency can be difficult, however, inverse functions make it easy to convert to a different currency and then back to the original. In order to convert from euros to dollars, you can use the function y equals 0.90868x, where y is the amount of US dollars and x is the amount of euros. You can use the function y equals x over 0.90868 to convert dollars back to euros. I hope you enjoyed this video on inverse functions and now know how to graph inverse functions.